Hello guys and welcome back to my channel Interview with Bunny, and today we are back with another video on system designing playlist, and the application or the system that we will be discussing today or designing today is one of the most critical topic of system designing interview, and that is the notification system. So if you have gone through my earlier video, you must be seeing that in most of the video I have used a third-party notification service to notify all my clients or the user. And what type of notification we were sending? For example, during the ticket booking application, we were sending the ticket as part of the email notification. Similarly, when we were designing the chat application, there we were sending the in-app push notification to the user. So in this video, we will be building that notification service that will help all our third-party application to send all the notification by our application. And the supported type of notification should be a in-app notification, a email notification, and a textual notification, or it can be a bank OTP. So since you guys are already familiar with what a notification server actually does or what a notification service can do, so let's start with today's video of designing the notification service and the first step of our designing, and that is the gathering of the functional requirement. So as I was telling you, the functional requirement of this system is quite simple and straightforward, because in this application we only have to support a handful number of functional requirements. So let's see what are the functional requirements that we have to support. So the first and the primary one, that we have to support all the three type of notification. It can be a email notification, it can be a SMS notification, or it can be a in-app notification. Number two, notification can be of two type. Number one, it can be a scheduled notification or it can be a real-time notification. So for example, in case of the OTP or any type of notification like this, it should be a real-time. Means whatever the event that is happening, we are just sending the notification to the user. But what can be a scheduled notification? So for example, a company or organization want to send a promotional activity or promotional notification to the user. At that time, it will be a scheduled one. Number three, whenever you are supporting a notification system, there one thing you have to remember, you have to give the user a template to form the notification. So for example, I am running Flipkart and I want all my users to get notified about different products based on some personas. So for example, one of my friend is interested to buy an iPhone, another user is interested to get notification about the Galaxies or Samsung phone. So what will happen, that we will give the user a fixed template where based on the persona of the user, means based on friend 1 or friend 2, the Samsung or the Apple text will get changed based on the user. I hope this is clear, that how we are creating a template so that it will be easy for the client or for the user to form the textual or the email message. Clear? Number four, whenever a client or organization is sending a message or promotional activity to his user, they would be interested to see what is the status of the message, means whether it was delivered or it is pending. So we have to give a dashboard to the user so that they can see what is the status of the notification. And the last but not the least, the fifth requirement is the end user of a particular organization should have the provision to change the preference of the notification. So for example, an end user doesn't want the textual message, rather he only wants the email message. So based on that end user preference, we should be sending the notification accordingly. So these are primarily all the 5 major functional requirements that we will be solving in this video. So let me list down all these functional requirements over here. So here you can see these are the functional requirements that we have discussed right now. So here you can see we are done with the first step of our designing, and that is the gathering of the functional requirement. Now since you are clear with what are the functional requirements of our system, let's now go to the next requirement, and that is gathering of the non-functional requirement, where we will see the scale of the system, means how it should perform based on different use cases, how would be the latency of the system, and all the properties of the system we will be discussing in our non-functional requirement. So let's see what can be the non-functional requirements that are relevant to our application. So the first non-functional requirement that we should point over here is the scale of the system, because the scale of the application is very crucial part to discuss at the very beginning, because without understanding the scale of the system, it is practically of no use of designing, because based on the scale, your design will vary accordingly. So let's see what will be the scale of this system. So here the notification system that we are designing is actually an industry level notification system, means any of the third party application can integrate with our notification service to send their notification. So for example, Amazon want to send all their notification via us. So you can understand that the scale of the Amazon is quite huge. So we have to also support that many amount of requests in our application. So for each and every order that are getting placed in Amazon, all this notification should go via us. So here the scale that we are supporting is around a millions of requests per minute. So here the first non-functional requirement will be the scale of the system, and the total number of requests that we are supporting is around 1 million notification per minute. Now the next important non-functional requirement is the cap theorem, and as you have already know what the cap theorem tells, that whenever you are designing a distributed architecture or a distributed system, you either have to compromise between the availability of the system or the consistency of the system. A particular module of a system cannot be highly consistent and highly available at the same time in case it is a distributed system. So here we will understand that based on the cap theorem, whether we should give the priority to the consistency or in the availability. So here if you look carefully and understand our application carefully, you will get to know that our system should be highly available rather than consistent, because you can easily understand that this system is a notification system. It is just sending a notification to the user that some event have happened, and it is not required that it should be highly consistent. So here the availability is much more crucial than consistency. And here the consistency doesn't mean the latency, means how quickly you are receiving the message. Rather, for example, as a user, I am changing the preference of the message or the template of the notification, and it is not required that as soon as I am changing the template of the notification, that template should get published to all the client or the end user that I am pointing to. It is fine that there is an eventual consistency or a delay of few seconds after which the new format or the new template get published or notified to my end user. So do not get confused here that the consistency and the latency are not same. So here, as I was telling you, based on the cap theorem, we are giving the preference of the availability more than that of the consistency. So our next requirement or the next functional requirement, that is our availability, will be more than our consistency. Now the third non-functional requirement, as I was discussing, is the latency of the system, means how quickly an event or a notification should go to the end user. And here, when I'm telling about the latency, here we can subdivide our latency into two categories. So for example, if it is a promotional notification or some event related notification, it is fine that the organization send the notification to the user with a small delay of 5 to 10 seconds. That is totally acceptable. But in case of the bank related notification, means in case of the OTP, it should be a near real-time notification, because if there is a delay in receiving the OTP, obviously that OTP will get expired and your entire authentication will fail. So here we will distribute this latency into two categories. One for the OTP where it will be in near real time, and another for the promotional message where we are supporting a delay of 5 to 10 seconds. I hope this is clear. So here you can see this will be our third non-functional requirement, that is the latency of the system. So here if you look carefully, we have almost covered all the functional and the non-functional requirement during our system designing interview. And based on this requirement only, we will be designing our application and we will try to fulfill all the points that we have listed over here. So let's now move to our second part of our designing, and that is identification of the code entity. And here if you go through all the functional requirements that we have gathered, Over here, you can easily identify that what will be the code entity that we can find out as of now. So first one will obviously will be the user. Number two, the notification preference, means whatever the preference that user is changing. Number three, the content of the notification, means the textual form of the content where the notification is going. Number four, the format of the notification, means the template. And the fifth is the delivery status. So these are primarily all the code entities that we can figure it out as of now by reading all this functional requirement. It can happen that while designing our application, we can find out some other code entities that are important. But as of now, just by reading this functional requirement, I think identifying these 5 entities is quite good. So let me list down all these 5 code entities over here. After that, I will tell you one more thing. So here, if you see, we have identified 5 core entities, that is user, notification preference, the content, template, and the delivery status. But here there is one more code entity that you have to figure it out. That is, here there will be not only a user, but there will be one more thing, that is client. And what is the difference between the client and the user? Let me tell you that. So in our earlier videos, what we did at that time, both the user and the client was same for us. But in this video, this user and the client are different. Let me tell you why. So if you understand, this notification system that we are designing is actually an industrial standard notification, means any third-party application can use our open API to invoke all their user any notification. So here all the third-party application, means Amazon, Flipkart, are actually clients to us. So here, if you understand, this client is not a person, rather it is an organization or an application who have incorporated or using our application to send notifications. So here, if you understand it correctly, here the client is nothing but an application like Flipkart or Amazon. And what are the user? So here the user are nothing but the person who are using this Amazon or the Flipkart. So this user is actually a person who is using this application. Clear? And why we have to consider both of them, you will get to know soon while we will be designing. Because if you remember, we have taken a functional requirement, that is, we are setting the notification preference of the user. So here, obviously, Amazon will not be saving a user level preference in their application. Rather, it is a personal choice of the user that how he want to get the notification, whether he want to see the notification as a pop-up or he want to see the notification as an email. So it is the choice of a particular user, a person, that how the notification preference would be. And that is why here we have to consider both a client as well as the user. I hope this is clear that why we are considering both the user and the client as our code entity and how they are different. So keeping this thing in mind, let's start with our third step of our designing, and that is the API designing. So let's see what are the REST endpoint that we have to expose over here. So as you know, designing the API endpoint is actually quite easy if you have gathered the functional requirement correctly, because in most of the time API endpoint have one-to-many relationship with all the functional requirement that we have gathered. So let me first list down all the API endpoints that we need for supporting all our functional requirement. So here, if you see, I have listed down all the API endpoints that we need to support all our functional requirements. So let's go one by one. So the first endpoint that we have designed over here is to send the notification template. So this will be done by our client. So what they are doing here, they are saving a notification template with the help of a post endpoint. And obviously, since they are saving a template in our database, means we are inserting some data in our database, means it should be a post endpoint. Clear? So this will be our first endpoint by which a client is creating a template in our application to send a notification. Number two, since a particular template can have multiple versions or multiple format, so here we are giving one more API endpoint to see all the template based on the template ID or the template version. Along with that, there will be few more endpoints to update or delete a particular template. So that will be our first endpoint that we need to design a particular template. Now, since the template is designed, now what we have to do, the client have to invoke the message or invoke the notification to their user. So what we are doing, we are exposing our next endpoint, and that is a post endpoint where with the help of this notification URL, the client will be sending few of the data. That is number one, the template ID which he have configured over here. After that, the recipient ID means which user he want to send that template or send that notification. After that, the variable. So for example, a particular user is interested to see all the notification of the iPhone sale. Another user is interested to see some other product. And based on that persona, the variable will get updated accordingly and the real life notification will get triggered to that person. Clear? After that, we have the channel. So what the channel stand for? The channel is nothing but a SMS, a push notification, or it can be an email notification. After that, we have the priority. So the priority can be medium, low, or high. So for a promotional activity, it will be of the lowest preference. But in case of a OTP, it should be of the severe or the highest preference. So that is why we are setting a priority variable over here. And after that, we are giving a schedule that means the client want to trigger the notification at a particular instance. Then at that time, here he will be giving that timestamp, and based on that timestamp, the notification will get triggered to his user. So I hope this is clear. Then the next endpoint is like, for example, you want to see the status of a particular notification. And for that, here we are giving an endpoint to see the status of each and every notification that is going through our system. And the last but not the least, here we are having the user preference. So here, for example, a particular end user of a particular organization want to change the priority of the notification. So for example, he only want to see the email notification rather than the push notification or the SMS notification. So at that time, what we are doing here, we are giving a endpoint for that user to set the notification over here. And as you can see, I have already given a sample payload that how it will look like. So here you can see this is a client ID. So it will be a Uber or a Flipkart. After that, here we are having the external user ID, means the actual person for which we are forming or personalizing the notification. So that will be his user ID. And after that, here we are having the preference, means here you can see he is interested to see the email notifications. So it is marked as true. Similarly, he is not interested to see or receive notification in the form of the text or SMS. That is why it is marked as false. So here with the help of this endpoint, a particular user will be able to set their notification preference. I hope this is clear that what are the major core endpoints that we have to expose to our client by which they can use our application. So I hope you are clear with that what are the functional and the non-functional requirements that we are supporting. Now since we are done with our third step of our designing, now let's go to the fourth step and one of the major step of our designing, and that is the high level designing of our application, where we will see what are the core modules that are required to fulfill all the functional requirements that we have gathered so far. So without wasting much time, let's go to the fourth step of our designing, and that is the high level designing of our application. So the first and the primary thing that we have to design in our high level designing is nothing but the client who will get actually onboarded into our application. So here we will be having our first component, and that is the client for our application. So these are nothing but our clients, and as you know, here the clients are not the user, rather the organization who are using our application to send the notifications. I hope this is clear. So here we are having our clients. Now, as you already know, this is a microservice architecture because here we have to support a huge amount of scale of the system and we cannot go with a monolithic architecture. So obviously we need an API gateway or a load balancer at the very beginning of our system. So here what we'll do, here just after the client, we will be having our next module that is nothing but a load balancer or our API gateway. I hope this is clear. So these are some of the basic steps of the system designing. Now let's see what are the microservices that we have to include over here to fulfill all our requirements. So the first thing that we are supporting is the template creation. So for example, before sending a particular notification, our clients, that is the Amazon or the Uber, have to set a template for our application. And that is why here we will be having our first service that is called the template service, where all the type of templates we will be saving into our database. So here we will be having our first service called as our template service, and since Here we have to persist all our template in our backend. So obviously here we need our database called as the template DB. So here we will be having our first database called as the template DB. I hope this is clear and quite straightforward. So the request will first come from the client, and based on the URL endpoint that we have defined over here, the request will get routed into our template service. And from there, the template needs to get saved or persisted in our backend. For that, we are having our template DB. Clear? So I will just mark it over here. Now the next small thing that we have to support is a user preference. So here if you have seen that we have created a separate endpoint to support all the user related things, and obviously we have to save all this preference into our backend. And to save it, what we are doing here, we are introducing another service called as the user preference service. And obviously all this user preference should get persisted in our backend, so that based on the user preference we can send the notification accordingly. So that is why here we will be having our next database, that is the user preference team. So here also it will be the same thing. The user preference request will come to us via this client service. So it is quite obvious a third-party user cannot invoke our application. So it should come via the client that we have registered. So from this client, the request will come into our user preference, and from there, the data will get persisted in the user DB. Clear? So we are done with the two major steps, that is the template creation and the user preference service. Now the main important thing is how we are sending the notification to the user. And here in our high level designing, just to show how the flow will work, we will just black box everything and we will show the component in a very high level. And what we will do, we will simply introduce one major service, which is nothing but the core service or the core microservice of our application. So all the requests will come into our notification service, and just by checking the user preference, what we will do, we will send the notification to our user. And how we majorly do it, we invoke a third-party notification provider by which we send the notification to the user. So for example, if we want to send an email notification, what we do, we use a third-party service, maybe a SMTP service, maybe a Gmail server, or maybe a Amazon server, and with the help of that, we actually send the textual message in the form of the email. So here, what we are doing, based on the channel that a user have configured, we have to send the notification accordingly. And here in the high level, we will simply show it as a simple component, and that is a third-party notification system, which we will call as a notification provider. So here I will mark it as a notification provider. I hope this is clear, but how we will be sending it, how we will configure it, and what are the strategy we should define over here, that we will define in detail in our next section, that is the low level or the deep dive analysis, where we will see in detail that how each and every service will interact with each other and how we will send the notification in real life. So here if you see, this is actually the high level designing of our application, by which we have only shown that what are the major components that are needed to fulfill all the functional requirement that we have defined over here. That is, here we are having a template service to create the template. We are having the user preference service to take the preference from the user. And here we have black box, the major service, that is the notification service, by which we are triggering the notification with the help of a third-party notification provider. But all these things we will see in detail in our next step of our designing, and probably the most crucial step of our designing. So let's go to the fifth and the last step of our designing, and that is the deep dive analysis of our design. Before proceeding further, I just wanted to notify that I have created a very simple website over here, so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist, where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website, so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So let's start with the deep dive or the low level designing of this application. So the first thing that I will do, I will copy this entire high level designing and I will paste it in our low level section. So that here we can expand each and every functionality and we can go into the deeper understanding of how each and every component will work. So the first thing that we will do is we will expand the template service that we have defined. So till now, I hope you got the idea that how the clients and the API gateway and the load balancer is behaving. So until this point, there is no change. Only thing that you have to mention in the deep dive or the low level designing is the responsibility of the load balancer and the API gateway. And as you know, the responsibility of the API gateway and the load balancer is authentication and authorization, routing and the rate limiting. And here the load balancer will be following the round robin algorithm. Clear? So these are some of the basic knowledge that you have to know about the load balancer and the API gateway. But one more thing you do not forget to mention during discussing about the responsibility of the load balancer and API gateway, and that is the rate limiting, because here rate limiting is very much crucial at each and every stage in our designing. So later in this video, I will tell you that how and why you should implement the rate limiter over here. But as of now, just keep the note that the responsibility of these two are as follows. Now let's go to the first module of our designing, and that is the template service. So what this template service is actually doing? The responsibility of the template service is very simple. That is, it is just an API endpoint or an API service by which the client are saving a template into our database. So here what is happening? With the help of this template service, it is simply creating a JSON payload or something by which a template is getting created in our database and it is saving it into our template DB. So let's see what will be the table that we will be using over here and what will be the schema structure of the table. So the template table is basically a very much a relational database. So over here, what we will do, we will simply use a NoSQL or a Postgres database. So let's see how the schema structure of this template DB will look like. So this is how more or less how the schema structure of the template DB will look like. So let's see what are the attributes that are needed over here. So the first one is the template ID, which is an auto-generated ID. After that, the name of the template. Then comes the type, means whether it's a promotional message or it is a transactional message. Clear? After that, we have the channel. So let me tell you why channel is important over here. So obviously a template for a SMS will not be same for a template for an email, because our email can have much more description with lots of image and lot of data, but an SMS message should be as concise and as precise as possible. Otherwise the user won't be seeing the promotional message in the mobile. So that is why for each and every channel there should be a template for the client. Clear? After that, we have the content, means actually the message that we are sending it to our user. Then our variable, as I've already told you. After that, we have the version, since we are supporting different versions of the template in our backend. After that, there is a flag like whether the template is active or not. Then we have the created date and the updated timestamp. So these are more or less all the metadata or most of the metadata that we need for each and every template that we are creating in our backend. So this will be the schema structure of the template database. I hope this is clear and quite straightforward. So here we do not need any more service or enhancement in our template service. Now let's go to our next service, and that is our user preference service. And what I will do, I will simply change the position of the user preference from here to at the bottom. So now let's see what are the components and how this user preference service will look like. So what will happen is like, for example, there are thousands and thousands of clients for a particular notification service that we are maintaining or designing over here. And for each and every client which we are handling, they might have millions and millions of users in their backend. And it is quite obvious that about 60 to 40% of their client will be changing the preference of their messages. So obviously 50 to 60% of the millions of users is also a huge number. And for each and every user, if they are changing the metadata or the preference of the messages, so all the requests will come into our user preference service. And obviously when we are changing the preference of the user service, so what we have to do, we have to update this user preference DB, because obviously we have to save all this information in the database. Means whether the particular user want to receive the message in the form of the email, SMS, or as an in-app message. So all this information should be persisted in the DB, and it is quite obvious that if we are receiving millions of requests per minute for the user preference service, it is not a feasible solution if we just directly update the database directly. So what we will do here, we need an additional service or an additional streaming platform. So what we will do here, we need a buffer service, and that is why what we will do, we will create a Kafka broker over here, so that whatever the changes the user is changing, that will first submitted into our Kafka broker, and from there our preference consumer service will read all these changes of the user, and it will slowly update it into our user database. So here what we are doing, here we are using a simple pub/sub technique to update the database in our backend. So here what we are doing, here we need a Kafka broker, and this Kafka broker will have a topic called as the user preference. So all the user preference changes are coming into this topic, and from there, here we will be having one more service, that is our consumer service. We will call it as user preference consumer, and this user preference consumer will consume the data from the Kafka topic, and it will simply update the user preference DB. I hope this is quite simple and the straightforward approach if you have already followed my previous video. Now let's see how the schema structure of the user preference DB will look like and what type of database that we will be using over here. So if you understand the user preference metadata, that is the thing we are saving over here, is nothing but this one. And this is quite a structural one and a relational one. And that is why what we will do is, since it is a very simple object, we will be using a simple Postgres database to save all this user level metadata. So let's see how the schema structure of the user preference DB will look like. So this will be the schema structure of the user preference DB. So here we have an ID, which is an auto-generated ID. After that, we have a client ID, which can be nothing but Amazon, Flipkart, Uber, or whatever. After that, here we have the external user ID. I hope you already know what is the external user ID all about. After that, we have the preference, that what is the preference a particular user want to set in the backend, and thereafter we have the updated timestamp. So this is how the schema structure will look like. So here if you look carefully, we have solved two of the most important things, that is the template service and the user preference service. So there are few more upgradation or few more enhancement that we have to do so that we can scale it properly and we can enhance the performance of the system. But all those things we will see once we require all those things and once we are done with our notification system. So now let's see the most important thing and the core functionality of our application, and that is how we will design this notification service. So let's start with designing this notification service. So what will happen once the client of our application want to send a notification to their user, they will send a simple request into our load balancer. And the request of sending the notification will get routed into our notification service with the help of the API gateway that we have defined. That is a simple, straightforward flow. Now what will happen? Once the request comes into our notification service, what we have to do, we have to see that how we can send this notification to the user. So in our high level designing, what we have discussed, that here we will use an additional component, that is a notification provider, which we have completely black boxed in our high level design. But right now we will see that what this notifications provider are all about and how it will take the data from the notification service and how it will push it to our user. So what actually happens is, like, this notification provider is actually a third-party application, or it can be our own application, but it is a different protocol that it will be using to send the notification. And since here we are using a microservice architecture, we will divide this entire notification provider into three major components so that we can separate out the responsibility to each and every microservice. So here what I will do, I will divide it into three components. One is for the email notification, one is for the SMS notification, and another is for the in-app notification. So let me first design it. After that, I will explain you how each and everything will be working. So here you can see I have divided the entire notification provider into three major components. So what is happening whenever our client wants to send a notification to the user based on the way they want to send a notification, the request will go to that service provider. So for example, for a particular user, our client want to send it with the help of the SMS notification. So the request will go from the notification service into our SMS service provider. Similarly, for another user, if a client want to send it with the help of an email, then from our notification service, the request will go into our email service provider, and thereafter the email will get triggered to that user. I hope this is clear. Similarly, the same thing will happen for the in-app notification. But the thing is not at all simple the way it look like, because here the SMS provider, the email provider or the in-app notification provider cannot send the SMS, email or the in-app notification directly to the user. So what they have to do, as I was discussing, there should be an external service that is required to actually trigger all this notification to the user. So for the SMS service, what we do, the most commonly used SMS service or the SMS provider are Twilio or MSG91. So let me write all these things. After that, I will tell you what these things all about. So here you can see I have drawn all the external services that we need to send the SMS, email or the in-app notification. So for example, for sending the in-app notification, what we need the FCM or the APNS service provider. So what this stands for? So FCM stands for Firebase Cloud Messaging, which is supported for the Android. So any notification that you are sending to an Android mobile, that you have to send with the help of the FCM service provided by the Google. Similarly, for any type of iOS notification for the iPhone or so, we have the APNS, that is the Apple Push Notification Service, which is supported and developed by the Apple. So for sending any type of actual notification in the mobile, which is nothing but the in-app notification, for that we need an external service, that is the FCM as well as the APNS service provider. I hope this is clear that why this external service is actually needed to send the message, email or whatsoever to our user. Similarly, for sending the email to our user, we need the SendGrid or the Amazon SCS, or it can be the Gmail SMTP provider or whatsoever, but we need some additional external service to do so. Similarly, over here, for sending the SMS, we need the Twilio or MSG service. So if you want or if you have time, go through all this documentation and all this information from the internet. So here you can see with the help of the Twilio, we can send textual messages as well as the email. Similarly, here if you see the SendGrid, which I have mentioned over here, is also the part of the Twilio. But now the main concern is how the notification service that we have declared over here will route the traffic to the SMS provider, email provider or the in-app provider. Because if you look carefully, here what we have considered, the scale of the system is 1 million notification per minute. It means that at a particular minute, this notification service have to route millions of requests between these three servers, which is actually not a feasible solution or a feasible way to transfer data between the services. So what we have to do, this is actually a bottleneck and this is actually not a scalable solution. So let's see how we can enhance this solution. So here the main problem is how this notification service, after receiving the request from our client, send the data to our separate service provider that we have configured. And the easiest and the most scalable way by which we can optimize this solution or we can scale this solution is with the help of a broker or a buffer in between this complete flow. So let me tell you how we will introduce a Kafka broker here also, and how with the help of the PubSub technique we will solve this entire problem. So let me introduce a Kafka broker over here. After that I will explain you that how this notification service will dump the data into our Kafka broker and how it will get delivered to all the service provider that we have configured. And also there will be a pro and the cons with this approach, and we will also see how we can optimize that too. So let's first introduce a Kafka broker in between. So here if you see, I have introduced a Kafka broker over here and I have named it as a notification queue. So what is happening, whatever the notification requests that are coming from our client, the notification service, which is nothing but a microservice, will receive that notification from our client and it will simply dump it into our Kafka broker, and it will not consider that whether it is a SMS notification, whether it is an email notification, or whether it is a in-app notification. It will blindly dump it in the Kafka broker, and from this Kafka broker, each and every provider service that we have will consume the data from this Kafka broker, and thus this provider service is nothing but a separate consumer service for each and every channel that we are supporting in our application. But how this consumer service will identify that which data are relevant to it? It is with the help of the topic that we will be defining within this Kafka broker. So let's see what are the topics that we should define within the Kafka broker so that each and every provider can identify that this message is relevant to us and we should consume that and we should send it into our external service. So let's see what are the topics that we should define within this notification service. So here I have mentioned all the topics that are needed into our notification queue. So let's go through it one by one so that it will be easy for you to understand. So here if you look carefully, when we were doing our API designing, there we have mentioned one thing, that is the priority of the notification. Means a priority can be low, medium or high. So what can be a low? So a low is a promotional message, a medium can be a standard message, and the high is nothing but the OTP and any bank transaction notification. So these are the three priorities or the three levels of notification that we are actually supporting in our application. And here also if you look carefully, all the topics that we have defined are based on that only. That is, a notification can be of critical type, a notification can be of standard type, as well as it can be of the promotional type. Clear? So that is why we have three types of notification, and for each and every type there will be three types of channel. So for a critical type there will be email, SMS as well as push. For the standard also it will be email, SMS and push, and similarly for the promotion also we have the email, SMS and push. So that is why here is the 9 permutation and combination by which a simple notification can be defined. So here you understand that how minutely we have to configure all those things so that all the flow works seamlessly. So here right now if you understand, all the notifications are getting landed into our notification service, and thereafter based on the channel and the severity of the notification, we are simply dumping the result or dumping the notification into our notification queue. And from these topics, this consumer service or the consumer provider that we have defined will actually consume the message and it will forward it into the external service. So what will happen? This SMS provider is only and only interested with all the messages or notifications that are related to SMS. I hope this is clear that how intelligently we are diverting all type of notification into separate notification provider. I hope this is clear until this point. Now there is one more thing that you have to know, that is here if you look carefully, we have also mentioned few other topics, that is the retry topic and the DLQ topic. So what is retry? So for example, one of the notification is failed to get consumed by our consumer service, so it will go into our retry queue, and thereafter after an exponential amount of time it will again try to consume that message, and in this way if it is failed to consume after two or three times, however you have configured, it will simply go into the dead queue. Means this SMS or the notification cannot be sent to the user, and the support team have to manually see that what is the problem with that notification and they have to solve the problem. And that is why we are giving a DLQ over here on the Kafka broker. Similarly, we are also having a bulk email notification. So for example, an email need to be sent in bulk to many customers. At that time, we are also pushing it in the Kafka broker. Similarly, if it is a bulk SMS also, we will be similarly pushing it into the Kafka broker. Clear? So I hope until this point, this is clear that how we are configuring this Kafka broker. Now, if you look carefully, there is a very critical thing that is missing. That is, once the client is sending a particular notification, it is coming into our notification service and thereafter it is getting pushed into our Kafka broker. But in this entire flow, there is nothing that is getting persisted in our backend. Means if any case our client want to see that what is the status of a particular message or the notification, our service will fail to do so, because here in this entire flow we are not saving the notification at all that we are sending to our client. So that flow is missing. So what we have to do here, we have to introduce another database to persist whatever the information or whatever the notification that we are sending to the user. So, and to introduce that, what we will do here, we will introduce one more database called as a notification DB. So let me first draw this thing. After that, I will let you know how the things will work over here. So here you can see I have introduced a notification DB. Now let's see how the data will go from the Kafka broker into the notification DB. So here also we will use simple consumer service to consume the data. So what will happen here, we will be having one more service called as a notification consumer. And what this notification consumer will do, whatever the data that is getting ingested within our Kafka broker, it will simply consume it over here and it will ingest it into our notification DB. So to persist each and every notification that we are sending to our client, we have to introduce this flow of saving all the information into the DB. I hope this is clear that why this is needed and what is the functionality that it is performing. Now let's see what will be the schema structure of this notification DB and what is the database that we will be using over here. So this is how the schema structure of the notification DB will look like. So this will be also a simple Postgres database. And let's see what are the attributes that we need in our notification database. So here we have the notification service, then the client ID, external user ID, template ID, channel, payload. After that, we have an important field that is called as a status. And the status can be pending, scheduled, sent, and whatsoever. Then we have the priority, schedule lag, and the last updated timestamp. So what will happen over here that whenever the data will come into our notification Kafka, this notification consumer service will consume the data and it will simply persist it into our notification DB with the status as pending. Means the notification had came over here, but it is not still sent to the user, and that is why it will be marked as pending. Clear? Now once the notification is consumed by the notification providers that we have defined over here, what we have to do, we have to change the status of the notification into this DB. So what will happen? From each and every notification provider, we have to update the database that we are defining. So from here, from the SMS provider, email provider, as well as from the in-app service provider, we have to update the status. Means the data that was there in the Kafka, we have consumed it, and right now since it is consumed and it is sent to the external service, that is why the status will get updated to sent. Clear? So right now the status got changed from pending to sent. Now it is still not delivered. So here you can see how we are changing the status of this notification at each and every step of our flow. But if you look carefully, this process of updating the database is not good, because here you can see this notification DB is getting written by multiple service provider that we have defined, which is very bad system designing approach. So here what we have to do, we have to do again something different. That is, these service providers should not update the status of the notification DB by itself. They should use some other way to update it. And how they will do? Here also we will use a Kafka broker to do so. So let me tell you how we will do it. So what I will do, I will just enhance this thing a bit. After that, I will tell you how the things are working over here. So here if you see what I did, I introduced a Kafka broker to get all the delivery status from each and every provider. So once a SMS or an email got sent to our external broker, what it is doing, instead of directly updating this notification DB, it is simply pushing that event into a Kafka broker. And from there, this delivery consumer service will consume the delivery status and it will update the notification DB rather than each and every microservice directly updating the database together. Clear? So here you can see how we are maintaining the flow or how we are updating the status of our delivery. So if you look carefully into our system, we are almost done with each and every step that we have defined in our functional requirement. That is creation of the template, creation of the user preference, and how we are sending the notification with the help of this notification service. So it is nothing but a simple Kafka broker with different amount of topics, and from this topic each and every provider will consume their message, and based on the preference and whatsoever, it will simply send the notification via external service. I hope this is clear until this point. Now, if you look carefully, there are few more functional requirements that we also have to fulfill. That is the reporting service that we have defined. So here, if you look carefully, though we are updating the status of each and every notification that we are sending, but there is no way by which we are sending this report to our external client, that is nothing but Amazon or Uber. So for that, what we need here, we need an additional service to do so. So what I will do here, I will define one more service called as a reporting service. And what this reporting service will do, the request will come from our load balancer into our reporting service. Means, for example, our user want to see the report or the analytics or the status of all the notification that he have sent. So from where it can get all the report, it can easily get the report from the notification database that we have created, because this notification DB have the information of this status field, and with the help of the status field only, this reporting service can send all the status of the notification. Clear? So this is nothing but a read request that will go from the reporting service to this notification database. Clear? But here, if you look carefully, there is one more step that is missing. So for example, here for each and every notification that we are sending, here the reporting service is only fetching the final state of the notification. Means once it is in the database and it is updated with all the status, it can only fetch the status after that. Means it does not have the report of each and every step and at what time it got triggered. So for example, a client is interested to see that when the notification got scheduled, after that when it got actually sent, when it got delivered, and all the minute level of status change, we are actually not persisting in the notification database. We are just updating the status over here, which is the final status. And here, to save all the minute status change of each and every notification, we actually need one more database to have all this micro level status change. So for that, what we'll do, here we will introduce one more table or one more database. So what I will do here, I will introduce one more simple table or simple database called as a notification event DB. So let me first introduce it. After that, I will explain you how it will work. So here I have introduced a notification event DB, which is nothing but a BigQuery table. And this BigQuery table will have all the micro level of information of the status change. So this delivery consumer service that we have defined over here, this delivery consumer will do two things. One, it will update the status of the notification DB, as well as it will ingest each and every request or each and every status of the notification in this notification event DB, that is nothing but a BigQuery table. I hope this is clear that how we are ingesting each and every notification related status change into two tables, that is the notification DB as well as the notification event DB. Now, if you want, you can just distribute this delivery consumer service into two microservices. One is the delivery consumer and another can be any analytics ingester service. So basically the main requirement is we have to ingest the data in both the table over here. Now, how the reporting service will consume the data? It will consume the data from both the table, that is minute level of status change or event that was generated for each and every notification. It will fetch it from the BigQuery, and all the final status of the notification, it will fetch from the notification DB. I hope this is clear that how this reporting service will consume the status related information from both the table and how it will show it to the user. I hope this is clear until now. Now there are few more enhancements that we have to do. So the first enhancement is that here, if you look carefully, we are having the user preference service where all the user preference are saved in this database. But here, if you see, this entire system is not interacting with this flow at all. Means though we have captured the preference of each and every user in our database, but this notification service is not at all bothered about the changes the user have made for their preference. So to do that, what we have to do here, all the service provider that we have introduced over here have to do one more thing, that is before sending the SMS or the email to the external service, it have to first check the user preference DB. That is whether the user is actually want to see the SMS or not. And if the preference is marked as false, means he is not interested, then we will discard that flow altogether. So all the provider service that we have defined over here have to talk with the user preference DB before sending the message to this external service. I hope this is clear that how the things are working and how we will use this user preference DB to configure and send the relevant message to the user. But here we have to consider one more thing, that is it is not good that for each and every SMS that we are sending or each and every email that we are sending, we are scanning this entire user preference DB on each and every request. So to omit that, what we will do, here we will introduce a user preference cache so that the provider service do not have to hit this expensive database. Rather, it will simply hit this caching service to get all the irrelevant information of the user so that our system will be super quick and much more optimized. So here what I will do, I will introduce a user preference cache. Clear? So here you can see how we are using the preference that we have saved for each and every user. So I hope you have thoroughly understood until this point. And if you look carefully, we have solved probably everything that we have discussed so far except one more critical point. That is, in this flow, if you look carefully, there is no way we are actually using the priority of the message. Means though we have said the priority flag over here as high, low or the medium, but in this entire flow, all the messages or all the SMS are following the same path. Means though we are setting the priority to a message, but we are actually not reducing the latency of that notification because here all the flow are same. But before solving that problem, there is one more critical issue that is there in this design that we have to solve. Because without solving that problem, this system will actually fail in real life. So if you see and look carefully into the system, here you will see what will happen in real life. That is, for example, this client that we have defined over here want to send a notification to the user. So what it will do, it will simply send a request into our API gateway, and thereafter the API gateway will route the traffic into the notification service. And once it is in the notification service, it will simply push it into the Kafka, and this notification service will send an acknowledgement back to the client that we have received the notification and it will get sent sooner. But if you look carefully, the flow is not right over here. Because though we have pushed the data in the Kafka, but we have not consumed the data till now. And by anyhow, if our Kafka went down before the notification get consumed by our notification DB, we will lose this message forever. So I hope you got the critical point that what I mean to say. So for example, there is a message ABC that Amazon want to send to a particular user. So what is happening? The notification or the request is first coming into the notification service, and thereafter once the notification service pushing the message into the Kafka, it is simply giving an acknowledgement to the client, that is Uber or Amazon, that the SMS or the notification is received by our system and it will get sent sooner. But this is wrong, because right now once the message is in the Kafka, by anyhow, if our Kafka went down, what will happen? All the messages that are there in the Kafka will get lost. Means at that time, though we have told Amazon that we have sending this SMS, but in between we have completely lost this message. So that is actually a critical flow that we are missing over here, because the SMS or the message which we are receiving over here is not persisted before it is there in the Kafka. So what we have to do here, we have to do one more thing, and probably one of the crucial thing by which we write the ingester service. So here what we have to do, this notification service, instead of writing it to the Kafka broker, it have to write in the notification database. So here if you look carefully, we are directly writing into the table of the notification DB. So let me just write down all these things, and after that it will be damn clear to you that how this entire thing will work. So let's see what is happening over here. So right now this notification DB have two tables. Number one is the notification table and number two is the outbox table. So what is happening, once the request is received by the notification service, the request will get first right into our outbox table, and this is how the schema structure of the outbox table will look like. So here we have our outbox ID, the notification ID, the event type, the payload, published, and the creation date. So this will be the schema structure of the outbox table. So what is happening, once a particular SMS or a notification is received by the notification service, it will do two things. That is, it will write it to the notification database, as well as it will also write it into our outbox DB. And thereafter, once it is successfully written in this database, then it will send an acknowledgement to the client that we have received the SMS from your end and it will get delivered soon. Because right now we are 100% sure that since we have persisted that information in our database, right now there is no way if we will lose it in the system. Clear? Now, once the data is there in this Outbox DB, what we have to do, from this Outbox DB, we have to write a CDC pipeline. Means once there is a new data that comes into our Outbox table, that data gets written into this Kafka broker. So right now this notification system is not directly writing into the Kafka broker. Rather, it is updating this Outbox table as well as the notification table, and thereafter this CDC pipeline will write it in our Kafka, and thereafter the flow remains the same. Means right now we do not need this notification consumer service to ingest the data from the Kafka into our notification DB. So right now, instead of a consumer service, it will be a CDC pipeline. Clear? So with the introduction of this step, here we are guaranteed the durability of the message. Means once the message is into our system, there is by anyhow we are not losing the message. Clear? But with the introduction of this additional flow, there is one more problem that we have introduced. That is the latency of the system. Because previously what we were doing, we were directly ingesting the message from here into the Kafka, and thereafter it was getting consumed by the provider service. So that was a simple, easy and a fast flow. But with the introduction of this additional thing, right now the latency is increasing because it is right now getting updated into our Kafka via a database and a CDC pipeline. But this latency is fine, because if you look carefully, what we have taken into our non-functional requirement, that is the latency of 5 to 10 seconds, is fine for the promotional notification. So all the promotional or the standard notification that we have designed over here, or we are going to send to our user, will follow this path, and this flow will take way below 5 to 10 seconds. So we are actually on point with the additional feature of the durability. Now there is one more thing that is missing, that is how we will increase the latency of this critical message, that is the high priority or the OTP message. Because if the OTP message follow the same path, then it will also take 5 to 10 seconds to send the message to our user. So for the OTP message, what we will do, In case of the OTP message, we will not follow this path. Rather, we will follow the path that we have defined earlier. So here we will again connect this path, means in case of the OTP message, this notification service will not ingest the data in the outbox or the notification database. Rather, it will simply put it in the Kafka, and thereafter it will follow the same step that we have defined. Now, the similar question might arise that what will happen if we lost the OTP in between? So, if you see, in case of the OTP, there is an option of retry. So after 10 to 20 seconds when the OTP gets expired, in case we are not able to send the OTP to the user with the help of this flow, the user can opt for resending of the OTP, and thereafter another request will come into this flow, and thereafter we will consume it. I hope this is clear that how we are segregating the priority of the message with the help of the two flows that we are defining over here. So all the standard or the promotional messages will follow this flow, that is, it will go directly into the database, and all the OTP related thing or all the priority or the bank related message will come directly into the Kafka, and thereafter it will get consumed by our provider service. And also, if you want, you can write another consumer service to consume all the OTP related data and update it into our notification database. That is totally up to you. Now there is one more important enhancement that you have to do. That is, here if you look carefully, we are using three provider service to send all the notification. But if you see in this flow, there is also no way we are segregating that whether a message is a simple promotional message or it is a bank related OTP message, because for this SMS service all of them are same, though we have separate topic for each type of notification. So to introduce or to solve this problem, what we will do, here we will introduce one more service provider, that is nothing but a OTP service provider. I have simply defined it as a simple generic OTP service, but it can be of SMS, email, whatsoever. And this service or this consumer service will talk directly to this Kafka broker, and it will simply consume only the message from this critical topic. So whatever the standard and promotional will get consumed by this provider, and only the bank related and the critical message, SMS or the push notification will get consumed by this OTP service provider. Clear? Now if you want to enhance it more, means if you want to reduce the time or the latency of this OTP, what do you have to do? You have to improve the architecture of your system. What I mean? So here if you see, these are nothing but the consumer service, and whenever there is a delay in sending a message, means your consumer is lagging to consume the message from the Kafka. And when the consumer lags, when the producer is producing more than the consumer is consuming. So at that time only there will be a lag in the consumer service. And to omit that, what we have to do, we have to horizontally scale this OTP service furthermore than this ordinary service provider. So obviously there will be multiple replication of this service provider across different region of the globe, so that whatever the message that are there in the Kafka broker get consumed at a very fast rate, and there is no delay in the service. So here if you look carefully, I have more or less covered everything, almost everything that we have taken in the functional as well as non-functional requirement. And if you look carefully, we have also solved all the non-functional requirement that we have gathered at the very beginning. Means our system support millions of requests per minute. Then we have also solved all the latency related issue. Means here you can see we have set the priority of the SMS or the OTP related thing with the help of this new flow, and all the promotion related flow will go via this SMS and the email provider. I hope this is clear that how everything is working so far. But there are few more things that I need to tell you, because those things can come up as a part of the follow-up question. That is, If you look carefully in our application, we are changing the status of each and every message till send, but there is no way by which we can confirm that whether it is delivered or not, because it is completely depends on the external service that we have defined over here. So to get the delivery status of each and every notification that we have said, what we have to do, it is a simple thing, that is on each and every provider we have to open up a webhook by which this external service will send the notification or send the acknowledgement that whether the actual message was sent or delivered to the user or not. And based on that, we will send the status into our Kafka message, and thereafter the consumer will handle accordingly. I hope this is clear. Another one more thing is the rate limiting that I was discussing at the very beginning. Because if you understand, this is actually an external system that we have defined for the client. And this type of system requires a rate limiting, because it can happen that since we are exposing the public API to the front end, so some scammer or the hacker can burst our system altogether. So to handle all those fraud things, what we have to do, here we have to introduce the rate limiter in the API gateway and the load balancer, as well as before sending the message to the external service. Over here also, here we have to place our rate limiter. So here there will be one more rate limiter that each and every service or the service provider will talk to. And why it is required? Because obviously if you see, this service is also an external service, and this external service will have their own rate limiter, and if we just keep on sending more requests to this external service, then the total supported number of requests that is there, then all those message or the notification will get dropped or get rejected, and our user will not get the request or the notification that they want. So here we have to introduce the rate limiter both at the API gateway so that the spammer could not spam our system. Also, we have to set the rate limiter on the service provider so that we can control the total number of requests that we are sending to our external user. I hope this is clear that how we should define and design our notification system. And if you have liked this video, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my channel and you are always ready for your next interview. So see you on our next video where we will solve another problem on system designing. See you on our next video. Thank you.